Hi everyone. In this topic, we will introduce interval estimation. Now you will ask me a question that is, why calculate a lot of things? Then could we expect that the result we calculated out is the exact value of the estimation? Then I will tell you because it's a point estimate, so we cannot expect the result is exactly value. So in this topic, we will introduce the margin of error and the interval estimate. An interval estimate can be computed by adding and subtract a margin of error to the point estimate. So the result we calculated out is an estimation. So it will be shown in an interval estimate. So that is the point estimate that will add or subtract by a margin of error. So the purpose of an interval estimate is to provide the information about how close the point estimate is to the value of the parameter. So in this chapter, we will learn how to compute the interval estimate of the population mean mu and the population proportion p. So in general, if you would like to express an interval of an population mean, you can express it like this: the p bar that can add or subtract the margin of the error. And to estimate an interval of the population proportion, you can use the population proportion be added or subtracted by a margin of error. So, in order to develop an interval estimate of the population mean or the population standard deviation or the sample standard deviation, they will be used to compute the margin of the error. So in most applicants, if the standard deviation is not known, and the sample standard deviation can be used to compute the margin of the error. But when the context that makes us can know the standard deviation of the population, then we will say such cases is standard deviation of the population is known cases. And then we can use it to estimate the margin of error and help us to calculate out the interval estimation. So you can check your textbook on the page 375 pages. There is example questions that is each week the loyal department store, it will select a simple random sample of 100 customers in order to learn about the amount of the they spend per shopping trip. So based on the historical data, the department store now assume a known value of the standard deviation um, in their population, that is the USD 20. And then the historical data also indicate the population that will follow a normal distribution. So when you find it's a normal distribution and the standard deviation of the population is 20, then you can think about the normal distribution means that the shape of the curve in the distribution will be a bell-shaped curve one. And then that means you need to calculate out the uh, interval estimate by its standard deviation of the sample. And now you know the standard deviation of the sample is 20. So the first step is you need to calculate out the standard error of the sample, and this part has been introduced by our last week about the normal distribution and the population of the sample, and you can follow by such formulation, and then to calculate out the standard deviation of the sample, that is 2. So you can check on your textbook of the figure 8.1 to find such a result. That means in such normal distribution context, the mean of the sample is mu, and the standard deviation of the sample you get is 2. So using the standard normal probability table, you can find that the 95% of the value of the any normally distributed random variable that will be within positive or negative 1.96 standard deviation of the mean. So when the sampling distribution of the X bar is normally distributed, then the 95% of the S bar value must be within a positive and negative 1.96 standard deviation of the sample of the mean mu. So in the lowest examples, the sampling distribution of the X bar is normally distributed. So with a standard error in our sample is 2, and because we believe it will be within the 95% of the value we would like to calculate out in such confidence interval. So we will use the positive and negative 1.96 z value and multiply by the standard error value 2 to get 3.92. That is the margin of error for our sample 100 here. So you can also check that in figure 8.2, that is in such a normal distribution curve, you will get the mean of the population is mu, and the standard deviation from our sample is 2. But because we would like to calculate by the 95% of the confidence level, so the margin of error will be the z value by the 95% confidence level is 1.96. So we will use it and multiply by the standard error value to get such interval that is mu of the mean, that is mu at such 3.92 or deduct 3.92, and it's an interval estimate for the result of our sample that will be have 95% probability to locate it in such area. So the general form of an interval estimate of the population mean mu is can be expressed as the S bar to aid or deduct the margin of the error. So in our example questions, we can say its interval estimate of the mu is S bar that aid or deduct 3.92. So if we took many times random sampling to select out the random sample, you will find, for example, the first time you get such sample and its mu will be located within such interval, and the second times such interval, you will find its sample mean will be located within the original interval. Then the sample we get from those 2 times, they can be expressed by such formula, that is the S bar of the x1 or x2 that aid or deduct by the 3.92 that is follow the 95 percentage of the confidence level. But with the sample we get that its mean is out of the original interval. That means such sample cannot be expressed by such formula because its mean doesn't be located within the original area or the original interval. So we cannot express it like the standard formula we would like to express. So in such conditions, you will know any sample mean of the S bar that within the darkly shaded region of the figure 8.3 that can be provided as an interval that contains the population mean and plus or minus the confidence level of the z-value and multiple by the standard error of the sample. And because the 95 percentage of all the possible sample means are in the darkly shaded region, so the 95 of the all interval formed by such subtract 3.92 from the X bar or adding the 3.92 to the X bar that could be included in the population mean mu.